Now to convert a polar equation to rectangular equation. So here's our equations right here. Now these are going to be a little bit tougher, but let's know what we know. Tangent theta is equal to y over x, and r squared is equal to x squared plus y squared. So let's do this. If r is 2, let's square it. That means r squared is equal to 2 squared. Well, what is 2 squared? 4. And r squared is the same thing as x squared plus y squared. So therefore, r equals 2 is the same thing as x squared plus y squared equals 4. Woohoo! Not so hard now, is it? Maybe not. Let's look at the B problem. Theta. Well, what is theta equal to? Tangent theta is pi over 3. Well, that means tangent pi over 3 equals y over x. What is tangent at pi over 3? It's square root of 3. So that if I multiply side by x, y equals the square root of 3 times x. Hey, now I wrote that one in a formula right there. Y equals square root of 3x. And I got that from my tangent theta. So how am I going to do this one here? Well, remember, x is equal to r cosine theta, and y is r sine theta. So if x is equal to r cosine theta, remember this. R is also equal to x, divided by cosine theta. So now I'm going to take that x divided by cosine theta and replace it with the r. And I also know that 1 over cosine is the same thing as secant, so x secant theta is equal to secant theta. And therefore, if I divide each by secant, that means x equals 1. That particular graph is just a straight line up and down of x equals 1. Because when I divide each side by secant, it cancels out. And secant divided by secant is 1. So therefore, the graph is x equals 1. So, what have we learned today? About polar coordinates. They're not always at the north or south pole. We can have multiple ones, different ways of writing it with positive and negative angles and positive negative r's. We can convert from polar to rectangular. Because remember that polar is the r theta. We know that theta is x, tangent theta is y over x. And the r squared is equal to x squared plus y squared. And we know also in the so we have the rectangular to polar, which we can do too. And we can do it with equations, both ways. So we're going to work on page 680, 5 to 48, and 57 to 64. And don't forget to bring your coat. Now, I don't really have to bring your coat. Coach Stoney, it's May.